And now let's have a look at the sources, the reasons for heteroscedasticity. And the first source of heteroscedasticity has to do with the error learning behavior of humans. So in this type of models, as people learn, the errors of behavior become smaller over time. Therefore, the variance is likely to decrease. And this graph represents this fact. So if you look on this axis, this is hours of type in practice. So this is x variable, this is the independent variable, and y, this is the type in errors. So, and when we at the beginning of x values, so when we have just few hours of type in practice, the type in errors are obviously bigger, there are more of them. So as you can see, the spread of the error terms in this case is bigger, so the error terms are higher. However, as the hours of type in practice increase, as we practice more, obviously the number of type in errors decrease, and this is represented by the fact that the error terms are now less spread out, so they're closer to each other, they are smaller, and as x keeps on increasing, the spread is getting smaller and smaller. So in this case, the variance of the error term is decreasing. Another source of heteroscedasticity, another reason of heteroscedasticity has to do with the fact that when our incomes grow, we have more discretionary available income, and hence we have more scope for choice about the disposition of our incomes. So in other words, when our incomes grow, our consumption increases, so we tend to spend more. And in this case, the variance of the error term is likely to increase. So once again, as income increases, our, let's say, desires get bigger and bigger, and our consumption consequently increases as well. Another reason for heteroscedasticity is the presence of outliers. We already discussed them a few lectures before, and on this graph you can see an example of an outlier. So this is the observation that is very, very much different from the rest of the observation. And in this case, we have the example of stock prices against consumer prices, and in this case, Chile is very far away, being an outlier. And probably because of this outlier, we will get the problem of heteroscedasticity in this data sample. And one more reason for heteroscedasticity is the omission of important variables. So, and again, this is me once again emphasizing the importance of making sure that you have included all the variables into your regression model. As you can see, if you miss some important variable, you might encounter the problem of heteroscedasticity. Therefore, make sure that when you come up with the theory, make sure that you are able to get all the variables for your regression model, and if you see that you cannot get the very important variable, maybe it's better to restrain from the analysis that you decided to undertake in the very first place. And three more reasons for heteroscedasticity is first of all skewness in the distribution of one or more regressors, for example, income, wealth, and education. Unfortunately, this is true. There is a very big gap between incomes of people, right? In some countries, it's not that big, right, where the middle class is strong, but however, there are a lot of countries like in Brazil or Russia where the difference between incomes is enormous. So, right, there is a huge gap between income of, let's say, of a low-class person and income of a high-class person, and there is a very small middle class in the middle. The same reasoning applies to wealth, right? So again, there's a huge gap between the wealth of people. Education as well. Unfortunately, still in some countries, there are either very educated people with higher education and people who haven't even finished the primary schools. Unfortunately, this is still also the case for our planet. And two more reasons has to do with incorrect data transformation. So, for example, if you calculate the ratios of your variables incorrectly, or you include constant prices instead of current prices, and so on and so forth. And incorrect functional form. So let's say instead of, for example, using a linear model, you decide to use a logarithmic model, and this might be the source of heteroscedasticity. And a very important fact that I would like you to be aware of is that heteroscedasticity is most common in cross-sectional data. So to be honest, I don't think you will ever see heteroscedasticity in time series data. Therefore, when you will be dealing with cross-sectional data, be aware that very, 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 very probable there is the problem of heteroscedasticity in your data set.